think you understand gravity. Step on a scale. You see a number. That's your weight. We say that's gravity. Earth is pulling me down. Sounds simple. Drop a pen, it falls. The moon goes around the earth. Planets go around the sun. Everything with mass attracts everything else. Newton figured that out hundreds of years ago. So we think, okay, gravity is a force. End of story. But here's the strange thing. That story is not just a little wrong. It's deeply wrong. Because gravity is not really a force at all. And when you finally see what it really is, the whole universe starts to look different. Let me show you. Stand up for a moment. Feel your weight. What are you feeling? You probably say, gravity pulling me down. But think carefully. What do you actually feel? You feel the floor pushing up on your feet. That's it. You don't feel any mysterious pull from the earth. You feel a push. Always a push. Never a pull. Interesting, isn't it? We talk about gravity as if something is grabbing us and dragging us downward. But in daily life, you never feel that. You only feel the ground resisting you. Now here's something even stranger. The moon is falling toward the earth right now. It has been falling for billions of years. And yet, it never crashes. It just keeps going around. Always falling. Never landing. What kind of pull works like that? A pull that goes on forever, but never finishes the job. And according to Newton, this pull works instantly. If the earth moved, the moon would feel it right away. Across empty space. No delay. No messenger. No signal. Instantly. How? Newton himself didn't know. He called it action at a distance, which was a polite way of saying, I don't know how this works. But his math worked beautifully, so people stopped worrying. When the equations work, we tend to stop asking questions. That's human nature. But sometimes those uncomfortable questions matter. To see why, we have to go back in time, hundreds of years. Before anyone really understood how the planets moved, Copernicus said the Earth goes around the sun. Fine. But in what shape? What path? Tycho Brahe spent his life measuring the sky, night after night, year after year, with simple metal instruments, no computers, no telescopes like today, just patience and precision. He wrote down exactly where every planet was. Johannes Kepler got this data, and he tried to fit it to circles. Because circles are perfect, right? But it didn't work. Mars was off by a tiny amount, just 8 minutes of arc. Most people would ignore that. Kepler didn't. He trusted the data more than his ideas, so he threw away his theory and started again. After years of work, he found the answer. Ellipses. Planets move in stretched circles, with the sun at one focus. And suddenly everything matched, beautifully. But now a new question appeared. Why ellipses? Why not circles? What is making planets move this way? At the same time, Galileo was rolling balls down ramps. Simple experiments. Nothing fancy, but very deep. He noticed something. If a ball rolls without friction, it keeps going. It doesn't need a push. It just moves forever. That shocked people. They thought motion needs effort. But no. Motion is natural. Stopping is what needs explanation. This idea became inertia. Things want to go straight. If nothing stops them, they do. So now we have a puzzle. Planets should go straight, but they don't. They curve. Something is constantly bending their paths. What is it? Newton saw the answer. Inertia says go straight. Observation says they curve. So something must be acting on them. He called it gravity, a universal attraction. Every mass pulls every other mass, stronger if it's bigger, weaker if it's farther away, and it drops with distance squared. One simple law, and suddenly everything fits. Ellipses, orbits, apples, moons, tides, all explained. The moon is falling, but it's moving sideways fast enough to keep missing, so it falls around the Earth. An apple falls for the same reason, just on a smaller scale, heaven and earth. Same physics. For 200 years, this worked perfectly. Better than anyone could imagine. It explained almost everything. Almost. There was one strange detail, a hammer and a feather. Drop them in a vacuum, they fall together, exactly together. No difference. But wait, the hammer is heavier. Gravity should pull it more. And it does. But it also resists motion more. And these two effects cancel perfectly. Always. Why? Why should they match so exactly? Newton had no answer. It was a miracle that made the math work. Or maybe it wasn't a miracle, maybe it was a clue. And that's where Einstein comes in. Einstein asked a strange question. What if that perfect balance was not an accident? What if it was telling us something deep about nature? He imagined a simple situation. You are inside a closed room. No windows, no doors, no way to look outside. You feel your weight. Your feet press into the floor. Are you standing on Earth? Or are you inside a rocket in empty space, accelerating upward? At exactly 9.8 meters per second squared? Can you tell? Drop a coin. It falls to the floor. Throw a ball. It curves downward. Stand on a scale. Same number. Everything looks the same. There is no experiment inside that room that can tell the difference. None. This is amazing. It means gravity and acceleration are equivalent. They feel identical. So Einstein thought, maybe they are the same thing. Maybe what we call being at rest in gravity is really a kind of acceleration. Now comes the big idea. In Newton's picture, gravity is a force. It pulls things. In Einstein's picture, something radical happens. Objects in free fall feel no force at all. None. Zero. Think about it. An apple falling, the moon in orbit, a satellite, an astronaut floating. All of them are falling, and all of them feel weightless. No strain, no pressure, no force. They feel normal, because they are moving naturally. Nothing is pushing or pulling them. They are just following their paths. So Einstein asked, what if falling is not being forced? What if falling is the natural way things move? And what if it only looks like acceleration because space itself is curved? Here is the idea. Mass does not pull. Mass bends space and time, like putting a heavy ball on a rubber sheet. The sheet curves. Now roll a marble nearby. It follows the curve, not because something grabs it, because the surface is bent. In real life, it's not just space. It's space and time together. Space-time. Earth bends space-time around it. The sun bends it more. Big things bend it a lot. Small things bend it a little. Everything makes dents in the geometry. Now think about the apple. In empty space, it would move in a straight line forever. But near Earth, straight is no longer straight. Space is curved. So the straightest path points downward. Toward Earth's center, the apple is not being pulled. It is following the straightest possible path in curved space-time. What about you, standing on the ground? You want to follow that same natural path, downward through space-time. But the ground is in the way. It pushes you up. It prevents you from falling. That push is what you feel as weight. Not gravity pulling. The floor pushing. That's it. You are being forced. The apple is free. When the branch breaks, the pushing stops. The apple becomes free. It falls. But in Einstein's view, it is not accelerating. It is finally moving naturally. You, standing still, are the one being accelerated. Upward. By the floor. Strange, isn't it? Standing still requires force. Falling does not. Einstein made a prediction. If gravity is curved space-time, then light should bend. Light has no mass. Newton's gravity shouldn't affect it. But curved space should. So during a solar eclipse, scientists measured starlight near the sun, and they saw it bend, exactly as Einstein said. Later, we saw it everywhere. Galaxies bending light, making rings, arcs, distorted images, gravitational lensing, direct proof that space is curved. Now think about astronauts. They float. We say zero gravity. That's wrong. Gravity up there is almost as strong as here, about 90%. So why do they float? Because they are falling all the time. The station is falling. They are falling. Everything is falling together at the same rate. So nothing presses on anything. No push, no weight. It feels like deep space. Free falling gravity feels the same as floating far away, because it is the same. Equivalence in action. Earth itself shows this. Why is it round? Not because some force squeezes it, because space-time curves equally in all directions. Matter follows those curves from every side, and the natural result is a sphere, like ants walking on a globe. They think they walk straight, but their path curves. They don't notice. We are like those ants, moving through curved space-time without realizing it. Everything near Earth follows these curves. Planets, moons, balls, light, you, me, all of it. No invisible strings, no mysterious pulse, just geometry. Mass tells space-time how to curve. Space-time tells matter how to move. That's the whole story. And from that idea, everything else follows. Once you understand gravity as geometry, something amazing happens. All the extreme things in the universe start to make sense. Take a star. A star is just a huge ball of hot gas. It has enormous mass, so it makes a deep dent in space-time. Everything around it wants to move inward, follow the curves, fall toward the center. Why doesn't the star collapse? Because inside, nuclear reactions are exploding outward, pushing, heat, pressure, energy. Outward push balances inward curvature. Perfect balance for millions or billions of years. But nothing lasts forever. One day the fuel runs out. The nuclear fire weakens. The outward push fades. Now there is nothing to hold the star up. Space-time wins. The star collapses. If the star is small enough, it stops. Matter packs tightly. Electrons resist. Atoms push back. You get a white dwarf. If it's heavier, even that fails. Electrons are crushed into protons. Everything turns into neutrons. A neutron star is born, a city-sized object with the mass of the sun, so dense that a teaspoon would weigh 1 billion tons. Space-time there is wildly curved. If the star is even more massive, nothing can stop it. No pressure, no particles, no known force. The collapse continues. The curves become infinitely steep. All possible paths point inward. Even light cannot escape. That is a black hole, not a thing, a region. A place where space-time folds in on itself, near a black hole. Straight lines spiral inward. Light goes in, never comes out. Time slows, space stretches. Everything behaves strangely. We cannot see black holes directly, but we see their effects. Gas falling in, heating up, glowing, releasing enormous energy, then vanishing, all predicted, all observed, all from one idea. Mass curves space-time, and everything follows those curves, even in our own solar system. This matters. Mercury's orbit shifts slightly over time. Newton couldn't explain it. Einstein could, because space-time near the sun is curved just enough. Tiny effect, but measurable and correct. GPS satellites use this every day. Their clocks tick differently, because time itself flows differently in gravity. Without Einstein's equations, your phone would be wrong by miles every day. So this is not abstract philosophy. It runs your life. Now think again about yourself. Standing here, right now, you feel solid, stable, still, but you are not. You are being pushed upward, constantly, by the ground, prevented from falling. You are fighting space-time, all the time, without knowing it. The natural state is falling, floating, free. Standing still requires effort, requires force, requires support. That is backwards from how we usually think. We imagine falling is dangerous, unnatural, wrong. But in the universe's language, falling is normal, floating is normal, following curves is normal. What is unusual is resisting. We live on a planet that constantly pushes us away from our natural paths. So we feel heavy, we feel grounded, we feel fixed. But really, we are riding a moving geometry through a warped universe every second. Now here's the beautiful part. From one simple principle, everything emerges. Planets orbit. Light bends. Time slows. Stars live and die. Black holes form. Galaxies evolve. Not because someone designed complicated rules, but because geometry plus motion is enough. Mass tells space-time how to curve. Space-time tells matter how to move. No extra instructions. No hidden machinery. Just structure and consistency and logic. When Newton discovered gravity, he showed us that the same laws rule heaven and earth. Einstein went further. He showed us that the stage itself is alive. Space is not empty. Time is not uniform. They stretch. They bend. They respond. We are not moving through a rigid box. We are moving through a flexible fabric that reacts to everything, including us, you. Right now, are shaping space-time. A tiny amount, too small to measure, but real. Your mass creates a little dent, and everything near you responds. The universe notices you in its own quiet mathematical way. So the next time you drop something, or look at the moon, or feel your weight, remember, nothing is pulling you down. You are moving along the straightest path, through a curved universe, and the ground is holding you back. That's gravity, not a force, a shape of reality itself.